Hello and welcome to Intermediate Algebra. This video is going to talk about how we divide a polynomial by a monomial. Monomial meaning a single term polynomial or a number. This follows the video for multiplying polynomials, and we will see some more rules of exponents involved in this. First, we're asked to divide 3x squared minus 6x plus 8 by 3. This is notation that means take this polynomial and divide it by 3. We more commonly use the fraction notation for division in algebra. You very rarely see that division sign once you move into algebra. So instead of doing that, we're going to use the fraction bar. The fraction bar, right here, is the fraction bar, means the same thing as this division sign. So we will rewrite our problem like that. And then if this were multiplication instead of addition and subtraction, we would only need to divide the 3 into one of the factors. But this is not multiplication. This is division. This is addition and subtraction. We have 3 terms. Terms are separated by addition and subtraction. What that means is you really have to do 3 separate division problems. You have to do 3x squared divided by 3, 6x divided by negative 6x divided by 3, and 8 divided by 3. And that is reflected below here. So now we can look at this as 3 separate division problems, but you must write it out like this. If you just divide the 3x squared by the 3, you will not have done the problem correctly. So looking at the first term, I have 3x squared divided by 3. Well, we can reduce fractions. Look at the numbers first and see if you can reduce the fraction. 3 divided by 3 is the number 1. So I can rewrite that as a 1x squared. We just don't write the 1. Now I look at this next term. Negative 6x over 3. The negative stays the same. Subtraction still. And again, 6 divided by 3 is a 2. So I get x squared minus 2x so far. And then 8 divided by 3, we use improper fractions in algebra a lot. Some of you are thinking, well, that's 2 2/3. When I learned my fractions and reviewed my fractions, I was told to write that as a mixed number. That's not as useful to us in algebra as this improper fraction where the number on top is bigger than the number on the bottom. So we just leave that as 8/3. I can't simplify that further. Had that number been a 9 instead of an 8, we would have written it as a 3. But 8/3 does not simplify, or it does not reduce any further is the point. So if it can't be reduced, you just leave it. So here's another one. Same problem. The difference here is instead of dividing by 3, we're dividing by 3x. I again set the problem up with my fraction bar. And I write each term as a separate division problem. So I have a 3x squared divided by a 3x minus a 6x divided by a 3x plus 8 over 3x. And I reduce each of these. So again, the 3 over the 3 becomes a 1. But where does this x come from? Well, x squared over x is the same as writing x times x divided by x. I see x divided by anything divided by itself, even if it's an x, is the number 1. So that leaves me with 1x. The other way to look at that is for the rules of exponents. If I have x squared divided by x to the first, in multiplication I added the exponents, in division I subtract them. That kind of makes sense. Multiplication and division are opposite operations. Addition and subtraction are opposite or inverse operations. That leaves me an x to the first. So that's where the 1x comes from. Now I look at the 6x over 3x. Well, I take the number first. 6 divided by 3 is 2. X divided by x. Anything divided by itself is 1. We simply don't write the 1 because 2 times 1 is still just 2. 1 is the multiplication identity element. My final term here is 8 over 3x. 8 isn't divided evenly by 3, and there's no x's to reduce, so I just leave that again. I know it might look funny, but you just leave that as it is if you were asked to simplify or to do the division, basically. You might not be asked to simplify this one, but the instructions would likely be divide. Okay. Next example. Okay, we have a longer polynomial. This time we have 1, 2, 3, 4 terms. And we're still dividing by a single term monomial. That's all we will do in this course. When you take pre-calculus, you will learn how to divide by higher degree polynomials. But for now, this is what we need to deal with. So again, I'm going to rewrite my problem as a fraction. I've rewritten this as a fraction, and then I'm going to take that fraction, and this time I'm going to get 4 separate fractions because there were 4 terms. So the 12x to the 5th becomes that term, and notice they're all over 2x squared. I haven't tried to jump ahead and simplify. I'm writing down every step. I recommend you do the same. Now, this time I have 12 divided by 2. That gives me the 6. X to the 5th over x squared is x to the 5 minus 2, which is x cubed. So that's where that comes from. For the next term, 6 over 2 is a 3. I keep the subtraction sign. X to the 4th over x squared is x squared because 4 minus 2 is also 2. 4 minus 2 is 2, sorry, not also 2. So that's my second term. That's how my second term reduces. So far they've both reduced. I look at the third term. 2 goes into 8 evenly. 8 divided by 2 is 4. X cubed over x squared, if I had written 3 x's on top, to write out x cubed longhand and 2 x's in the bottom, these and these would each reduce to be a 1. It would leave me with an x, or you could look at it as x to the 3 minus 2 because the 2 is on the bottom, is x to the 1st. We don't usually write the 1. And then the final term, I keep the subtraction. 10 over 2 gives me 5. And x squared over x squared is a number divided by itself, so I get 1. Not coincidentally, if I did this with the rules of exponents, I would get x to the 2 minus 2, which is equal to x to the 0. A variable raised to the 0 power will always give you 1. And the reason is, it could be rewritten as this, and if you get 1 using this algebra, you must also get 1 using this algebra. Okay, so that's, and what we will learn as we move into factoring is the fact that I have 4 terms, that the 2x squared went into each of the 4 terms. And it doesn't look like I have any other common factors in my answer. The 2x squared is what we call the greatest common factor. What this means is I can rewrite my original 12x to the 5th minus 6x to the 4th plus 8x cubed minus 10x squared. I can rewrite that as this answer times 2x squared, and we don't even need the dot for the times. If I were to multiply this through, I would get back this, and that's a way to check your work. What we do when we factor is we basically do this division, but then we do write what we divided by out front. So this big expression here is the factored form of our original polynomial that is represented in the top here. So that's all I have for dividing by a polynomial by a monomial. Take a look at the homework. Email me if you have questions. See you in class.